using today because we do have some new stuff that we're adding in. All right, so again, I'm recording. I meant to record the bellwork, but I forgot to start it. So we did a two-step inequality and we graphed it. So, and then the last thing is you do have to know how to create inequalities from word problems. It's the same exact thing that we do when we did equations. It's just you have a different symbol. Instead of an equal sign, it's a less than, greater than, less than or equal to, greater than or equal to. So we'll do that today for sure as well. So here are your steps to graphing. If you don't have them, there, that's the steps to graphing in green and then sort of in red. I had color, yeah. If you wanted, like, if you don't have a very good notebook and you just want to take notes today on this, that's easy to find, come grab one. If you just want to take it and staple it into your notebook, that's fine too. Otherwise, sometimes it's hard for you guys to find your notes. I will help you with that, but nobody's taking this one. So first step, we just went over this. Put the circle on the number that you came up with as your answer. Don't shade it in yet. Just put an open circle right where that number is on the number line. Now, if you have one of these, so I can't make it any easier than this, by the way. So if you're not writing this down, you're killing yourself. If it's one of these two symbols, then you fill it in. I've taken all math and logic out of it and just made it, it's not even memorization because you have it in your notes. All you gotta do is look it up and find it. So step two, if it's one of these two, then you fill that circle in. Because again, that means whatever the number is, it is part of our solution because it can also be equal to that number. That's what the little line underneath means, that our solution can also be equal to that number. Then last, you shade left or right. Again, I made it not even about math and logic, but just about memorization. Well, again, not even memorization. You can just look at your notebook. If it's one of these two symbols, then you shade left. If not, then you shade right. I didn't write that part in, so if you want to write that part in, you can. Boy, if I get people that don't shade it, you should always shade left or right. It's just now dawning on me that some people are going to think that it's not one of those two. They don't have to shade it. You always shade. It's just a matter of do you shade left or do you shade right? Well, if it's one of those two, you shade left. If it's not one of those two, then you got to go shade to the right. I guarantee I'm going to get people tomorrow not shading. Can you write this in there? Like, literally, that's the answer to half. Not half. Friday. But we got a lot to go. I'm going over the whole entire quiz today. Everything that's on there we'll go over today. So if you're not writing everything down today, when I come around on Friday and you're, oh, how do I do? What do I have? Whatever. Well, show me what you took from Wednesday. For all of you that are here today, at least. And I know the Aisha was out for a while. But if you can't show me that you took notes on today, don't expect much help. So, oh, this last piece, the variable must be on the, well, actually, one of you does do this in here. So this is important to you. If you solve this out and you get the variable on the right, because you move the variables to the right instead of the left, like we've been doing, this doesn't apply. The shading part will be wrong if you do it. You need to get the variable on the left first before that's going to be correct. The way you get the variable on the left, you don't just switch the 3 and the x. You have to also flip the symbol. It's kind of like it's a mirror image and you're actually turning it all the way around. Well, this would spin all the way around too. The symbol would spin all the way around as well. So once you flip it around, then you can use that last part of it, the step 3. But if the variable's on the right, then that number 3 will not work for you. You'll get it, you'll do the opposite, you'll get it wrong. Any questions on that piece? Again, 5 two-step inequalities where you have to solve and graph. I don't think I even make you graph the longer ones, you just have to solve them. All right, so now let's go ahead and practice some of the other stuff. So estimating rational and irrational numbers. Did that work? Nope. There we go. Maybe. Really? There we go. All right, so I wasn't going to rewrite all of this. I will erase some of it. I am going to rewrite some. Not all of it. That takes a long time. All right, so when we estimate irrational numbers, you're also going to estimate rational, but we'll come back to that in a minute. This is what we did with a little square root symbol.
Right now.
I would. I'd write every single thing that I said today. As much as I could get down, because again, it's all strictly based or about what's on the quiz. So we said that there is what does that symbol mean around the 8? What's that mean? What's called a square root, what's it mean?
To get the answer, times the number or something.
Some number times itself, so it's got to be the same exact number. Some number times itself equals 8. Well, here's the problem with that. There is no number. There's actually physically not any number at all times itself, like decimals or fractions or anything. There's no number that times itself equals 8. It's an irrational number. That's kind of the definition of an irrational number. Well, I take that back. There is a number times itself that equals 8. It's this number right here. Square root of 8 times the square root of 8 equals 8. That's the only number. There's no fraction, there's no decimal, there's certainly not a nice round integer times itself that equals 8. Because here are the only integers, when we multiply them times themselves, these are the only numbers they can come up to be. 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16. Write all those things. That's going to help you on the quiz as well. It mainly saves you time, but if you don't understand it, then it actually will help you.
Can you go back up a little bit?
I'm going to go back up in a second, but make sure you write all these down first. Yeah, no, we're going to go back up and do the other part. So first, though, write these somewhere where you can find them later when you get to the estimating irrational numbers questions. There's 2 questions, by the way, where you estimate irrational numbers. One of them, that's all you do. You just have to estimate. You do have to show me how you've got the estimate, which I'll talk about. The other one, you have to do 2 things on it, and I'll go over that one separately in a minute. So for you guys that are online, your test might be a little different than the test they take here. I'm going to actually probably try to ask you some verbal questions as well. I'm going to see if somebody can come in to watch the class while I sit and ask you some questions. So be prepared for some questions on Friday. I forgot to tell the last class there. I see them again tomorrow.
Bueno.
All right, so hopefully you've got all that written down. Again, these numbers that are circled, they are called perfect squares. I'm not going to quiz you on vocabulary, but you may see that on some kind of state or district test. So these are the numbers that you use to try to help you figure out when you have numbers underneath square roots like this. Because, like I said, there's no one number times itself that's going to equal any of those. But we can use these perfect squares as kind of like a guideline to figure out, well, what's a good estimate for those other irrational numbers. So, for example, hard to explain sometimes, so we'll just do them. I hate it when it does this. Now, there we go. So we want to know what number times itself, or at least as close as we can get, equals 8. Again, not a number. There's no one number that you can say absolutely times itself is going to equal 8. We know that there are some other numbers, though, that do come out to be nice round integers when we multiply them together. Which two would you use on the left out of those ones that are circled?
Oh, no.
What would you use?
Well, not,
Well, what out of the circled numbers, what would you use?
oh, 9.
9, and then I saw Samantha said 4. So we would use 9 and 4 because 8 falls right between 9 and 4. This is why I said write all these down, because this is the exact process you will go through on the test, on the quiz on Friday. You'll find whatever number I give you, you'll just look at all the numbers you wrote down and find, well, where does that number fall in relative to these circled numbers? Well, in this case, we fall between 4 and 9. So that means that's the two numbers we use. And we know what those equal. We got it right here. We know the square root of 9, and you should know these anyway, I think. We know the square root of 9 is 3. Nice round integer. We know the square root of 4 is 2. Nice round integer. Well, if the square root of 8, or if the number 8, you can almost say, is in between these two, which it is, it's a number line, so as the numbers get bigger, they go up. Well, the square root of 8 can't be above 9 because 8's not a higher number than 9. If the square root of 8 is closer to 9, we said, then the estimate that we come up with, like this is going to be our estimate, we're going to come up with a number, that estimate needs to be closer to 3 than 2. So for example, we could even fill in, we could say, well, square root of 5 would probably be way down there, close to 4. Square root of 6 probably be somewhere right there, a little above 5, kind of getting closer to the middle. Square root of 7, again, kind of closer to the middle, but it's a little closer to 9. And then square root of 8 would be somewhere closer to 9. So you don't have to show all of those out when you do it on the quiz. I'm just trying to give you an idea of this. This works the same way just a regular number line works. As you go up from, like this is 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, they go up. Well, it's the same way when you're dealing with square roots. As the numbers go up on the number line, they're going to get bigger. Their value is going to get larger. So that means the value over here is also getting larger. But it's not going to be a nice round number. It's going to be a decimal. We're going to have to estimate it. What would you estimate? Who am I going to call on? Tyler. Can you give me an estimate for the square root of 8? What do you think? Given everything I've just written up here. What's it going to start with? What's first number going to be? Well, I think you might be finishing it off, but first, so the first number is what? First number's got to be 2 because it's going to be a decimal number, but it's going to fall between 2 and 3. So 2 is the first part of it. I think this is what you're saying. Maybe if I'm wrong, then I apologize, but just follow along if I'm wrong. You need to understand what I'm saying. The first number has got to be 2 because the only numbers in between 2 and 3 are 2 point something. And there's an infinite number of them, so I can't write them all down, but as an example, we could say, well, 2.1 is down here, 2.2, 2.3, 2.4, 2.5, 2.6, trying to make them relatively close together. Probably should have split them up a little bit. So that's about where those numbers would fall on a number line. They just count up nice and evenly spaced. Well, 2.5 would fall at about square root of 6 or square root of 7. 2.1 or 2.2 would be square root of 5. 2.8, 2.9 would probably be a pretty good fit for the square root of 8. So 2.7 is not bad. It's going to be closer probably to 2.8 or 2.9 because they're all the way at the top, closer to 3, and this is all the way at the top, closer to 9. I think it actually comes out to be like 2.83 is the closest number. but I'd take 2.8, that's fine. So we would say, let me get rid of all of that. We would say that the estimate's probably about, again, it's not exactly 2.8, because there is no number times itself that exactly equals 8, but that's a pretty good estimate based on just where all these numbers are falling here, and then based on kind of the same number line going up on the right. Now let me ask you this question.
Excuse the interruption. PSAT standard testing rooms, you can release your students now to go to their 7th period. G6, G4, and A3A extended period classes should continue testing.
So here's my question to you now, to see if you're really getting this. And if you're not, this isn't actually on the quiz, but when you go to take standardized tests that you need to pass high school, this is the kind of stuff that's on those. How do I know for sure if that 2.8 is a good estimate? What's the test I should perform to check that? Anybody have any idea? Multiply what? Perfect. So here's what Christine just said. I think this is my estimate. I think that's a pretty good job based on everything that I knew. Like I said, we take what we know and then we do our best job to estimate. The way I can test that out is, remember, I'm saying that this number times itself should equal 8. That's how we started. Well, if I want to see if it's a good estimate, I just multiply it times itself and see if it comes out to be pretty close to 8. Now, you do not get a calculator on Friday, because otherwise this would be way too easy with a calculator. You just punch it in your calculator. But you could test it out and say, all right, well, 2.8 times 2.8. Oh, she's giving me my calculator. I'll do. All right. Well, we'll find out. Yes. Let me finish this out, Leanne. So you could test it out by saying, well, let me multiply them together, because if I multiply them together, they should come out to be, remember, not exactly 8, probably not even super close to exactly 8, but they should be somewhere fairly near 8. 8 point something or 7 point something, that's pretty close to 8. So 8 times 8 is 64, carry 6, 16, 22, 0, 16, carry 1, 5, 4, 8. So 7.84 is pretty good. So here's what you need to show me on the quiz, though. You can't just write down 2.8 and think you're getting 100%. It's too easy to just write down a number. You need to either go through and show me this, what we did here, like choose the two numbers, show me what their perfect square was, then show me where your number or whatever number I give you fits into that, then estimate. You can do it that way, and I will count that as showing me your work.
Question.
Yes?
We just do like a 9 and a 4 together to the 20?
No, oh yeah, good point. You don't have to do all of these. You can just do the 9, the 4, and whatever number I give you. Yes, just those 3 is all you need. You don't have to do all of it. Or if that's not making tons of sense to you, or if you feel like that's too much work, you could just do an estimate if you're like, well, I just kind of know what that is, and then you could show me this math and multiply it out and show me that it's pretty close to that number. And a lot of kids prefer doing this way. That's just how they estimate. They keep multiplying numbers until they get one that is close to the number. Like they'll start with 2.5, and if 2.5 comes out to be way too low relative to 8, then they just go a little bit higher and they do it all over again. Either one of those is fine with me. But you can't just write down a number and think you're getting a whole lot of credit. You got to show me something. So here's the next thing that's on there relative to estimating. This is the kind of problem I'm going to give you. Well, yeah, I'm going to give you. It's on there. It says convert. This is literally exactly what it says, just different number. It says convert these to a decimal and put them in order. I'm pretty sure it says from least to greatest, but if it's from greatest to least, you just flip the order around. We've already gone over how to convert this to a decimal. That's what we just did when we said the 2.8 was our estimate. This is already a decimal, so not much to do there. All we need to know now then is how do we take a fraction, and again, you won't have a calculator. How do we take a fraction and make that into a decimal? Trying to give you the answer already. No spoiler alert. Yeah, we just divide. This line always means division in algebra, we said. It doesn't matter what's on top and what's on bottom, even if it's a big long equation on top and a big equation on the bottom. It means the top equation divided by the bottom equation, or in this case, the top number divided by the bottom number. You don't remember how to do long division, because you, again, will not have a calculator. You take the top number divided by the bottom number, and then how many times does 5 go into 13? Twice. You multiply that together, you get 10. 30. 6 times 5 is 30. Well, and then once you converted them all to decimals, so we just converted this earlier, right? And we said, well, that's about 2.8. This is 2.2. That's not hard. It's already 2.2. And now we said this one is 2.6 because I just divided, I said 13 divided by 5 is 2.6. So now we have them in decimals and it's easy to put them in order.
What's that?
What?
Right next to. Oh.
I don't know what you
Right
mean by
next to
that.
decimal and put. I mean, right in between.
You gotta be more obtuse. You gotta give me more. Oh, this. That means and. Sorry, that's a short abbreviated version for the word and. Whoops.
That was deep.
Yeah, sometimes I do shorthand stuff, and I forget you guys haven't really learned some of the shorthand stuff. So yeah, decimal and there. Put it in order. So that's another problem. All you got to be able to do is convert. One of them is already a decimal, so you just got to convert the other two to a decimal. I think. Are you guys in the bathroom? I think you're away in the bathroom. So that's everything for rational and irrational. It's just 2 questions.
No.
And we just did both types of questions. Oh, this is how you, if you're wondering what this is how you do long division, or like, not long division, but this is how you change a fraction to a decimal. You take the top number and divide it by the bottom number. That's what that is. And I just gave you the example in the one we solved right there, 13 divided by 5.
Will there be word problems on this one?
Oh, yes. That's what we're about to do right now. Any questions on this first, though? It's 2 problems, but not super, super tough if you just follow the steps. Again, make sure you have your notes. Please don't anybody walk in and say, oh, I left my notebook at home. There's nothing I can do. I mean, I can't postpone your test because you left your notebook at home. So please don't forget your notebook. All right, that's all for that one. So we did word problems the other day. I did not put anything like this on there. I wanted to. I really, really, really wanted to, but I already had enough problems, so didn't. But there is one like this. So read that again. I'm going to go through and I'm going to do this one for you and just kind of walk you through it. And then you're going to try one to make sure you're good. And then we have another type of word problem as well. We already did that one. I know. Read through it again. Oh, yep, sorry. There's a reason why I'm doing this one again. Because if you can do this one, you should be pretty okay for the quiz. And the next one. This is easier than the one that's on the quiz. Same concept. Ah, so we did do it already, so wait. Did I go forward? I didn't go forward, did I? No. Okay, good. Yeah, we're on the right screen. So really quickly. I'll do this one and then you'll try one. So we go into Slurpee store. We got $24 to spend. If you're struggling with equations, here's the word version you can use. Well, this is how much money I have to spend. So that's going to be at the end. The money I have to spend. This is going to be how much I actually spend over here. I'm actually doing an extra step. I don't normally do this. How much you actually spend. I just need to figure out, because remember, it's not an equation, it's an inequality. So we got to figure out what sign we need to use first. What's true about the? Did you do that to me, or like did you intentionally just show me that you had your buddy? Again, I'm not going to get on people today about it, because if you don't get this for Friday and you were doing your own thing, that's on you. As long as you can hear me. So the amount I actually spend has to be what relative to the amount I have to spend? Well, we're not doing a number. We're just doing the symbol. What's the symbol we're going to use? That's the symbol I'm talking about. So the amount I actually spend has to be what? So the amount I actually spend can be greater than the amount I have to spend?
No, less than.
No, remember. Less than or equal to. Because if I walk in the store and I only got $24, I can't spend more than $24. So it can't be, this can't be greater than how much I have, right? I can't spend more than I have. So it has to be less than, or I could spend exactly. I could spend all 24 even. I just can't spend more than 24. You can't spend what you don't have. So that's the very first step in words. Well, now let's think, and I'm not even going to put numbers in yet. How much I actually spend is based on buying what? Slurpee was one, right? I bought a Slurpee, money on all Slurpees. And then what else did I buy besides Slurpees? I did not buy Sloopies. Slurpees. There. And then what else did I buy? I don't even remember. Airheads, that's right. Money spent on, and again, there's a reason why I'm putting in this word all. On the last quiz, when we did word problems, let me just real quick. A lot of you used the numbers that were the individual price number. Sometimes that's the right number to use, sometimes it's not. In this particular problem, it actually is the right number to use because he's only buying one Slurpee. So all the Slurpees is just one Slurpee. So that's why that individual price, the $3 or whatever it is, that's why it works in this one. If you remember back to the word problem about sandwiches and chips, though, he bought some chips, and we didn't know how many, but he also bought a bunch of sandwiches. You guys, not all of you, some of you, it was 6 sandwiches, no, I'm sorry, 3 sandwiches, and they were $6 each. So I got this equation over and over and over again. I use the 6 and the 3 in an equation like that. Thank you. That had nothing, the 6 and the 3 had nothing to do with the equation. I mean, not in that way. Okay? Yep. The 6 and the 3 were the cost of all of the sandwiches. You were just supposed to take those, multiply them together, and get 18. I don't know if I would say very few people did that, but not as many as I thought did that correctly. Most people did the 6 and the 3 thing as part of the equation. So that's why I'm putting that word all in there. You need to know how much is spent on all Airheads, how much is spent on all Slurpees, and then that amount has to be less than or equal to the total you have to spend. which I'll just say the same thing. We'll put numbers in on the next step. So now all we have to do is just fill this in with the numbers. Oh, why does it keep doing this? There. Whoop. Nope, that didn't work. Backwards now. There we go. So, how much, what's an easy one of these to fill in? Priscilla.
Slurp.
Ella. Which one? Okay. Slurpees is easy, right? What was that number? It's just 3, right? Because in this case, all of the Slurpees was just 1 for $3. I can still put in that stuff because that doesn't change. Cortez, what's another easy one? You need me to scroll back up? I'll scroll back up. There. Actually, I can probably show. Pretty close. You can kind of read the top part. Ah! So what's another one you can pull out of there and do pretty easily? Well, there is a 150. What is that 150 about? It applies to what part of the word problem? It's about airheads, right? It says right there. Airheads are 150. So it's about airheads. So what part of the equation is that going to go in? Again, this is it in words. What part of the equation is that going to go with? Well, does that say anything about airheads?
No,
Yeah, it's going to go with the part that's about airheads. So the 150 is the cost of airheads. Well, we're trying to figure out how much we spent on airheads, so we need to know that number.
Right now.
Huh?
Lost it right
I write everything I do today. What other part do we need that we haven't put in there? What do you think, Yasha? Yeah, that's an easy one to me. That's the easiest one. Where does that always go? Yeah, that's always, and again, you need to make sure it makes sense to be there. Like, don't just automatically, when you get a district or state test, put the biggest number at the end. But that's where I'd initially start looking. I'd say, well, does it make sense that that 24 goes at the end? Well, what he spends on airheads plus what he spends on Slurpees is going to be that. So yeah, in this case, it definitely makes sense that that goes at the end. What's the only thing we're missing? Yeah, we don't have a variable in it yet, right? What's the variable about? How do we define the variable in this?
How much airheads they cost?
So X represent the number, well, it's not how much he spent on airheads. The variable itself is the number of airheads he buys, but that's going to obviously apply. The number of airheads he buys is going to be a part of the cost of all the airheads. So the X would have to go with the 150. Again, the variable will always match up with one of the numbers in the problem. If the variable is about airheads, then it's going to match up with the number that's about airheads. If the variable is about movie tickets, it's going to match up with the number that's about movie tickets. What else we do? If the variable is about how many students per bus, it's going to match up with the number of buses. Those units will always go together. So when you're trying to figure out which number that X goes with, all you got to do is just match up with what the X stands for and then what other number is related to that same unit of measure. So that's your equation. I'm not going to worry about solving it out and graphing it. We've already done that as the bellwork. I want to get some more stuff done because we still have to do the new word problem. I want to do a longer example of an equation, well, inequality, and then I want you to do another estimating irrational and rational. So any questions? You are behind Kaylee for sure. That might be it. I think that might be it. All right. Because if it wasn't it, somebody else would have just spoken up. So no questions? So you guys do this one. Can you see that one, Christine? Aubrey loves pretzels. She goes into the store with $29. If a bag of pretzels is $2.50, write an inequality that represents how many bags of pretzels she could buy if, supposed to be she, if she also buys 2 Slim Jims for $2 each. So this one's a little trickier. And I'll tell you right now, it's a little more like what you're going to see on the quiz. And then it tells you let X represent the number of bags of pretzels, so that's pretty easy. Even though it did, the question also was how many bags of pretzels could she buy? So it matches up, but I just gave it to you. You will have to define X on the quiz, so you need to know X comes from the question. So how many bags of pretzels could she buy was the question. Well, I actually defined it, and I said let X represent the number of bags of pretzels. I kind of told you what it would be there. But you need to know how to do that on your own quiz. I don't think I gave it to you on the quiz. So mainly write the inequality. I'm not so worried about you solving it. You should be able to solve 2-step. If you are not sure that you can solve, then you can try it and I'll check it. But mainly I want to make sure you can set up the inequalities. I may solve it and grab them for you real quick for those of you who try. I'll give you, shouldn't take much longer than about 3 or 4 more minutes. I'll give you 4 minutes. You guys are at home trying this. Same thing. If you want to solve it out, you can. If you want to graph it, you can. But mainly this is about testing whether or not you can create the inequality. Yes, ma'am. You're behind, what do you say, no? All right. There should be time. We still have 30 minutes, so 35 minutes actually. Although I guess technically 25 minutes of bathroom break. You done? All right, you be working. Like I said, everything we're doing today is directly related to a question on the quiz. In the, not the one that says used, obviously the other one.
Wow, anyway.
I believe that looks good. Does that one not work?
That one,
If they don't work, if you pull the calculator out, don't throw it back in there. I'll get rid of it. Done? Hopefully I can see it. Good. Should be able to use the last example to give you a pretty good model for this. There's one little piece that's different, but not much different. Well, make sure so you set up the equation. Right. Good. And your solution looks good also. Okay, this one. Good. Anybody else has an answer? I'll check it. We still have a pass going? You guys need a pass.
He lost it.
Who lost it?
Yeah.
It fell off.
Wow.
How did it fall? How did it fall?
I use the bathroom. I don't know.
Mandy.
So, and I'm not saying you're doing it, just in case.
You better run the bitch over, okay?
If passes are found to be outside of this room and the teachers were not giving them, that's a pretty serious deal at this level, so.
Half of my classes, they get passes. Half of my classes, they don't give a pass. They just go.
I'm just telling you, sometimes in the past, I'm not saying you're doing this, but kids have thought they were slick by keeping a pass that's a generic pass and using it later. That's a pretty big deal at the high school level. So don't think there's anything you've tried that other kids haven't tried.
Bro, man.
I'm not saying he's doing it, but,
I said, I came back. I get on and came back.
well, I'm not saying you'd be using it right now. Or that they used it.
Let me tell you.
They just thought that they were pretty slick about it. And trust me, they got caught eventually.
You was shit.
No, it's not.
The house of that.
Oh.
House of that.
All right. All right, so timer went off. So most people that I've seen did a pretty good job. Some of you, I don't believe you are really trying. Either you gave up, which is not good, or you just didn't feel like trying, which is also not good. These quizzes are about partial credit just as much as they are knowing the math. So this is the same exact concept. So I'm going to skip some steps and go kind of straight to the first or the main wordy equation. So she's going to the store. She's buying two things. She's buying pretzels. So the dollar is spent on all the pretzels. Dollar spent on all pretzels. Plus the dollars. And this is where it differs from the last one a little. I mean, this part doesn't differ, but all Slim Jims has to be less than or equal to whatever money she has to spend. Can't spend more than you have, so it's got to be less than or equal to. So hopefully you have that less than or equal to something. Well, now we just have to take that and put it into numbers. So the money she has to spend is pretty easy. She has $29 to spend. That was an easy one. Oh, and you can mix these together at any stage just to get credit. Like if you're having trouble putting it into words, but you know that the amount that goes down there is the 29, you could write two things in words and then a number there. That's fine. It doesn't have to be all in words. Like just, again, do what you know. Don't just sit there and do nothing. If you can fill this one in because you know the number there, like on the last one, this number was really easy. It was $3 for a circle. Well, then you could put $3 here and then in words there and in a number of words there, whatever. You can mix this up however you want. Just try to explain to me what is going on in the equation, in the story. So here's where it was a little different than the last problem. They gave us the $3 in the last problem, and we just put $3 in this second number, the one-time number we called it before. Well, here it's $2 for a Slim Jim, but that's not what we put. And most of you got this right. It's on all the Slim Jims. That's why this word is so important every time you do it. Because sometimes it's not going to be just one item, like one thing of popcorn, one Slurpee. I can't remember any other examples where we did where it was one, but we need to say, well, how much were all the Slim Jims? And we know that because we know how much one was and how much she bought. It was 2 times 2. So in this, we had to do a little math to get that number, unlike the last problem where we just took the number 3. So just keep that in mind on the quiz, that it's not necessarily one of the numbers that's in the problem. You may have to do some math to get that number. And then over here, again, what numbers did we not use? We need the numbers that are about pretzels for this part, because this is the pretzels part of the equation. All right, well, what numbers are about pretzels? Well, a bag of pretzels is $2.50, so there's my one of my pretzels numbers. What else is about pretzels? Well, the amount I spend on pretzels is based on how much is one, and then times how many. Well, I don't know how many. I don't have a variable yet because x is the how many. So that's where the x would go. Again, x is about pretzels. It's got to go with the number that's about pretzels. That will almost always work out, certainly when I make the quiz. The units of measure have to go together in the equation. They just have to. You can't multiply the number of Slim Jims times the cost of a bag of pretzels and have that come up with anything you can use. It just doesn't even make sense. So those will always go together. If you solved it out, if you solved it out and I didn't check it, I think it came out to be x is less than or equal to 10. So you subtract 4, 2.50x divided by 2.5 divided by 2.5. X is less than or equal to 10. If we graphed it, which you will have to, you may not have to graph on the word problem, but you're obviously doing some graphs. So I would put, let's say it was 0 here, 5, 10, 15. Well, we don't need negative numbers because we can't buy a negative bag of chips. So I'm not even going to fill those in. X has to be, so first I put a 0 or a circle on the 10. That's the answer that I came up with. I fill it in because it could be equal to 10, we said, right? And then I just need to shade left or right. Well, I already gave you the quick version. If it's a symbol that has the less than involved, either it's less than or it's less than or equal to, then I shade right. Or I'm sorry, shade left. Probably didn't make you solve this out, I'm guessing, because, graph it out and solve it. Because technically that graph is not correct. You can't buy negative chips, so we couldn't say negative numbers are a solution to buying chips. So it doesn't really make sense. Our next lesson that we do is kind of about doing this type of problem in a better, more accurate version. I think I just heard somebody click. Well, maybe not. Nope, we're not. Guaranteed. All right. So that is one of the problems on your quiz, or something like that, I should say. All right, so let's talk about this one. This is a new one. This is the one we haven't done. It's not a whole lot different than what we just did, but we need to certainly go over it before you just see it on the quiz. How many people have done fundraisers? Did we talk about that in here?
Like in elementary school.
Yeah, anytime, any fundraiser anywhere. So when you do a fundraiser, what did you do for your fundraiser?
Give it to my friend.
Sold something. What'd you do?
I gave it to my mom.
No, what did you? What was your fundraiser? What did you do to raise money?
Oh, like cookies and all that. No, like,
Did you sell something or did you do something to raise money?
I did something.
What'd you do?
It was like a school thing. Like Yeah, yeah.
Oh, you sold some, okay.
Yeah.
Because sometimes you might do a fundraiser, you might wash cars.
Yeah.
That's what I'm asking. So, why have you sold stuff for fundraisers? You probably had, well, maybe you did, maybe you didn't. Sometimes in a fundraiser, you're raising money for a specific reason, like you want to go on a trip. Your team wants to go somewhere and you need money for the team to travel. That's pretty common. So there's something called a goal. You should know what a goal is, but in fundraisers, it's a very specific thing. The goal is, that's how much we want to raise. We need to raise at least that much money or we can't go on the trip. So we need to raise at least $1,000 or $2,000 or $3,000, whatever it is, in order to go on the trip. That's what this is about. So you're in a club. You want to raise money to go on the trip. All right, pretty easy to understand that. Most of you have done something similar. You want to raise at least $500. That at least part's pretty important. Some of you already know what that means just by reading at least. Some of you, it's not as obvious. And so far, you have raised $100. So we want to create an equation, an inequality, that represents this situation. We need to define x. I didn't say solve it. I don't think I say solve it on the quiz. We might still solve it. What can you tell me about this? Who am I going to call on? Manny. What can you tell me just in general about this? Anything about this situation? You can either read it again. You can just, if you can picture what's going on.
You need to raise
So we want to raise 500. At least. What does that mean?
like that's how much you're like trying.
What number? Give me a number you'd be happy with raising.
400.
You'd be happy with 400? Is that at least
30.
500? Did you raise 500?
No.
So would you be happy with 400?
No.
No. You wouldn't be happy with 400. What would you be happy with?
That's not even a door.
What
How
about
much?
499?
What's that?
What about 499?
Well, I don't know. You wanted how much? Did you get to 500 and you did 499? So are you happy then? I mean, you're not as upset as you would be if you raised 10, but you didn't hit your number. What's the number you would be happy with? 500 would be, you'd be happy with that. I'd be pretty darn happy with 1,000, right? I don't mind if I raise more than 500. Absolutely not. I'd be really happy with 1,000. So anything at 500 or above is what you want to raise. So you need at least 500. That's what the at least part means. Well, you're not going to be mad if you raise more than 500. You'd be more than happy with that. So here's the first part of this word problem. In very, very vague, big, general terms, the amount you raise, I'll just put the amount raised. No, I can't put that. I gotta be more specific. The amount you, boy. So the amount you raise, well, that's not particularly good. Hold on in, whoever's next.
Oh. Please hurry up.
I will.
Yeah,
This
this is who's
is
talking.
not famous.
So the amount you raise for your fundraiser, you want it to be greater than or equal to whatever your goal is. That's very simple. All right, please refocus. You guys have been good until now. I know it's a long, boring class. The more I cover, the more you have in your notes for Friday. So this is very, very general and vague, but I give points to that because you got one huge part correct, and that's that part right there. You told me you understand that you'd be okay with raising more than whatever your goal is, or equal to. So I definitely give some decent points to that, for considering that's all you did. I mean, it's not like I'm going to give that a C. But. So, and I do grade every single question individually when I grade your quizzes. You get 100%, 0, 50 on every single one, and then I average them all together. So now we just need to break some of this down and figure out, well, what goes where. The goal is a pretty easy one. We know what our goal is, it just tells us the problem. So that's going to be an easy one. So let's talk about the amount you wind up raising. What's the problem tell you about the money that you're raising? Or the money you, yeah, well, how do I explain this without giving it away? What? You want, well, that's the goal, but what about how are we raising the money? Selling candy bars, right? So we're gonna sell some candy bars. What's the X, the definition of X in this?
How many candy bars you selling?
Yeah, and there are questions somewhere in there, right? Don't we just take it straight from the question? So X is going to equal how many more, that's key, how many more candy bars you need to sell. So how many more candy bars? The more part is kind of crucial in this. So when we're all done with this, the amount we raised is going to be based on what? From this point in time, like this is a specific point in time. You got to kind of imagine where you're at. So how do we break this piece down into a better understanding so we can create an equation? Because right now, the amount we raise is pretty vague. I mean, some of you might be able to do the equation from there, but some of you, we probably need to break that down a little more. Because there's a bunch of numbers still going on up there. So look at some of the other numbers. What are we going to do with some of those other numbers? We already know where the 500 is going to go. That's pretty easy. I'll give you a hint. It's just like everything else we've done on these. There are two things that make this number that you're going to add together. There's two pieces that are going to get added together that are going to make up that number, just like everything else we've done.
How many candy bars do you need and how many?
Not exactly. We're going to use some of that. Where are we at right now? Let me ask you that question. In our fundraiser.
100.
We have $100, right? That's a flat number. That number is not going away no matter what, right? So the eventual amount we raise, I could say that, maybe the final amount, maybe that helps a little bit. So the from this point right now, right, now you guys are starting to do too much, doing too much of it. Again, day before a quiz, which I know it's not the day before, but for you it is. That's too much. The final amount you raise is made up of two pieces. It's made up of what do you already have, like how much money do you already have, and then how much more will you raise. So you would say the money you raise, I guess you could say from now on, and then plus the money you've already raised. So, as soon as I turn, you guys do all kind of stuff. So that's how you would break that down. You've already raised some, but you're not done. So you're going to wind up adding more money to that $100. And then when you add those two together, that will be how much you raised total, like your final amount you raised. And you want that to be more than your goal. So now we should be able to fill that in. I mean, that's not super complex stuff to fill in. Because one of the numbers is actually two of the numbers are just given to us. Kind of like some of the other problems. What's already just given to us?
100.
Yeah, 100, right? They said, gosh, darn it. So we know that we already have $100, right? They just told us that. Oh. I guess never mind, we'll do it later. So we know $100. They told us we've already raised 100. Still gonna have to be greater than or equal to the goal. Oh, actually, what else can we fill in? I probably shouldn't have written words because we're doing the equation part now. What else can we fill in?
500.
Yeah, we can fill the goal in, right? That was just given to us. That was just given to us in the equation, or in the word problem. So the only one that's a little tricky, in my opinion, is how much are we going to raise from here moving forward?
400.
Well, we need 400. We want 400, but how do we put that in equation form? What part of that do we know? What part do we know from this? How much we raise? How are we raising it? Selling candy bars, right? Well, don't we know some stuff that applied to candy bars? Yeah, and first of all, we haven't used this number, so that's another clue. Candy bars are $1.50 each. All right, well, if it's about candy, there we go. Then that $1.50 is going to be part of the money we raise moving forward. Every candy bar we sell, we're going to add another $1.50 into this money that we raise from now on. That $100 is done. We're not worried about that. We're talking about what we raise moving forward. Well, every time we sell a candy bar, that's going to give us some more money. So that's part of that number. What's the only other thing we haven't included?
X.
Yeah, we don't have a variable, right? We got to have a variable in an equation or an inequality. What is the is the X about the money we've already raised?
It's about the candy bar versus the
It's about what? It specifically is what? We wrote it down. It's how many more, right? Remember I said more was important? Because more has to do with what we're doing in the future. So the future, I could say in the future, that would probably have been better right there, but this is the future here. This is kind of the past. Well, this is about the future. So the 150 times how many we sell in the future, or how many more we sell, is going to tell us how much we add to that 100. If you solve that out, you could come up with, I don't know if that comes out exactly even. Probably, it might not. You might get like half a candy bar, which you can't have half a candy bar, so it wouldn't be a perfect model, but that doesn't matter. You don't have to solve this one out in the quiz. So it just says write the equation. But that's a pretty good example of how to handle one when you have like more like a goal instead of a budget. I'll leave it up for a second, then I'm going to do one more problem. This last one is just working out a really long, complex inequality. So hopefully you guys know how to do that. If not, though, follow along. It'll be recorded, so you can also go back and watch it the night before the quiz if you think you've forgotten stuff. There's some other videos I did that are based or will be on this quiz. So when I did the video on October 8th, that was solving out an inequality there also. If you want to see another problem solved out, it's on my YouTube. All right, so you should all have that. Again, it'll be recorded if you don't have it. So. All right, so that's the last one we're going to do right there. You want to write it down and try to do it on your own, that's fine. I'll let you get started. I'll give you a couple of minutes to do that, and then I'll just start solving it. At the bare minimum, you better all be able to do this. If you can't do this, you lose big points. If you can't at least do this left side of the equation, where the distributive property is, then I know you haven't learned a whole heck of a lot this year. And we haven't done it in a while, so this is your refresher right here. Or you can go online and watch videos on distributive property if you just want to look at that one piece. No matter what video you look up that says distributive property, it'll all be the same stuff. There's no other way to do the distributive property, unlike some things in math. only one way. I'll give you a minute, and then I'll start doing it. I think you're going to have a little more time on this quiz because I believe it might take you longer than some of the other ones. I could be wrong about that. If it doesn't take you longer, great. You can get it done earlier. It's just every time I don't get on you guys about doing phones and stuff, it reinforces why I don't let you have phones. People get so tuned out and not paying attention. Oh, I'm not looking at you right now. I'm not looking at you. I mean, I'm physically looking at you, but I'm not talking about you right now.
Oh.
Give you like 30 more seconds and I'll start solving out. You can kind of just keep doing your own and then look back and compare it. We'll have time to go through the whole thing. If you get stuck though, then you can just follow along with me. If you can do this one, you should be more than fine on the quiz. There are two problems like this, but I do give you the two-step equation you should get. So I'll point that out when I get to it. All right. So again, you should all be able to do this first step. Distributive property. This means you take the -9 times 7x, -9 times, I call it -8. If you said subtract -9 times 8, that is okay, but I think this is a cleaner way to do it in my opinion. I ignore the right side of the equation. I don't even look at it right now. I'm not even, I do remember, we do everything we can on one side first before we even look at the other side. So I'm just ignoring that side. So I get -60. The numbers are not this high, by the way, on the quiz. I just used really high numbers, so I didn't repeat any numbers that might be on there, because sometimes I actually accidentally do that. That's plus 72. A negative times a negative is going to wind up being a positive. So I'm at a point where I'm looking at this going, all right, well, I have a term with a variable and a term without a variable. I can't combine those. That's all I can do on the left side. I'm done on the left side. Now I can come back over. So that's going to still be less than something. Now I come back over and I can start doing the right side separately. So again, I do that. I cannot really. So here, I'm not going to be able to keep it up here, but I'll show it to you. So now I'm going to ignore this side. Now I'm just looking at the right side. All right? Totally ignoring the left side. I'm just going to work through the right side. Unfortunately, though, I have to get rid of that right. There. I have to get rid of that black stuff because if I don't get rid of it now, I can't get rid of it. It'll erase everything. So, and again, I said this before. If you have more than two terms on a side, you can combine something. Guaranteed. Because the only way you can't combine something is if you have one term with a variable and one number. If I add a third term in there, it's either got to be a number or it's got to be a term with a variable. It's got to happen. There's no other option. Unless you have more than one variable, which we're not close to doing that. So, I can combine something, so can I combine numbers or variables? Well, really shouldn't be going. I can combine the like terms that are the variables. Again, you're not getting how to combine those. It's just if I have 1x, because this is a 1 in front of this, even though we don't show it, but just think about it. If you have an x, think of it as a physical thing. That's an x, a single x in your hand is 1x. If I add to that 2 more x's, that's like saying I have x and then plus 2 more x's. So that's 3x. So that plus that comes down to be 3x, and then I still have the 7. So now I'm done on the right side. Term with a variable and a number. Nothing else I can do on the right. 3x cannot be combined with 7. This is now the stage where I start subtracting underneath and moving stuff around. Because I want to get all the variables to the left. Which means I need to get rid of the variables that are on the right. Well, to get rid of it, we do the opposite. We never multiply, we never divide in the middle of an equation. So we wouldn't do that. Is add or subtract. Well, if I added 3x, like let's say I thought I was going to add 3x, well, that gives me 6x. That doesn't move anything anywhere. So it can't be that. So that's wrong. That's totally wrong. So I need to come back up. I need to think, how do I get rid of that 3x? Well, I need to do the opposite. 3x subtract 3x gives me 0. That's what I want, is 0. So if I do it over there, I have to do it over here. Oh, draw your line. Do it in a different color. So now I can make sure I don't make the same the mistake of not doing something on the left side and the right side, or doing it twice on the same side. So this gives me negative 66x plus 72. I got rid of it over here. I just had the 7. Now it's a two-step equation. Hopefully you all know how to do it now. On the quiz, I give you a big, long problem like this. Then the next problem, the part B, if you remember how I had a part B is just a two-step equation you should get. So on the quiz, I would give you this, and then down at part B, I would give you this. So you know whether or not you've done it right to this point. If you haven't gotten that, then you've done something wrong. If you can't figure out what you did wrong, you can just solve out this two-step equation, and then you can get it right for that part of the problem. So you would just say, you know what, I can't figure out how he got that, so I'm just going to use what he gave me, and I'm just going to solve that. So you would just solve from here down. So our first step, we want x all by itself. We leave that for last, because that's going to be division, which means, and we never multiply or divide in the middle. Remember that? So we don't multiply or divide in the middle. Subtract 72. Oh man, this didn't come out right. Huh. I totally did that wrong in the other class. I mean, it didn't really matter, but the math was just wrong. Steps were right. So that goes away. Negative 65. And then over here I have negative 66x. Last step is divide. We bring the negative with us when we divide. Don't forget that. And last but absolutely definitely not least, don't forget to flip the sign. I just divided through by a negative.
0.98.
I don't make you graph it, so you don't really have to convert it to decimal. So you flip the sign to greater than. So x is.
Good afternoon, faculty, students. One quick announcement. All cross-country runners, please meet in H1.
X is 65, 66.
All your announcements. Have a great Patriot Day.
All right, so that's pretty much everything that's gonna be on the quiz Friday. I'll probably give you about an hour and 10 minutes on Friday. Since it's a pretty, I think it's gonna take a little while. We'll see. All right, so you guys that are online, I probably take pretty much the same quiz, but there will be some parts I will count more for you than the face-to-face people, since you can just use calculators and other stuff to figure some stuff out. I will also be asking questions at some point. Some of you have already done that. Some of you never responded that you wanted to do it. So if you still want to do it, you need to send me a message. All right. Have a good rest of the day.
Want me to put this one in here since I use it?
Yeah, absolutely.
Oh yeah. Oh, you just clean them.
I don't, but yeah, they get cleaned by the operations staff. Yeah.
Did they tint the windows?
They did.
His charger.